Voltage down to zero.
To get back to
I have
steady state.
disabled it. Right.
In other words, as soon as you start
Yeah.
turning
It's the same?
it, just now,
very
ideally
close.
would be, that would be satisfied
It's a
by
little
something that's
lighter.
not 50%. You
Huh,
need like a
interesting.
Yeah.
53,
Interesting. It's not
see, you
much.
know what I'm saying?
Okay,
For a given speed.
Right.
Okay.
Yeah.
We will need fancy NASA equipment to measure the resistance because I cannot feel it with my hand. But I don't have a DSP on my hand, so I don't know.
Right.
Oh, yeah. So fun.
All right, what else were we gonna see? Let me show you the stepper real quick.
What is this?
Tony, stand there. Stand there.
Okay, so here's a stepper. There's gonna be much to see, but a stepper is most of the time use open loop. So you really doesn't know if the motor is moving. You trust that it is moving, and you trust that it is moving at the speed that you're telling it to move. I am right now applying a sine wave to the stepper.
Not that cover, that cover.
Don't worry about it.
The front cover,
Don't need it.
yes I do.
Now, are you really applying that, or are you applying a chopped PWM approximation sort of thing? Is that how it's being synthesized?
There is a DAC inside of the device.
Oh, okay, literally has a back, okay, it's analog.
Oh, so you're microstamping it.
Yes.
Oh.
Looks pretty bad. Why? All the decay.
Sure, here. And that's done.
Okay, that looks
Yeah.
more like what it should. Depends on the decay mode. So basically, there is a controller inside that changes how much we're chopping the current at. So you saw on that other example that I can change the VREF, and that changes how much current flows into the winding. In here, the controller is taking care of this. And there are actually two phases. They have to be 90 degrees out of phase.
I need the front cover for that. Yes I do.
So all of that is taken care of by the controller. All you have to do is
Can you break these designs out that you created? They're pretty cool, actually.
Write you a program that will generate those.
okay. So as you can see, what I'm doing is just applying a pulse, right? A train of pulses. If I change the speed,
How would you?
the motor changes with the speed.
It can't come out because the gear's on there, Tony.
And this is just
This part.
one line of code. I just put it on my interrupt.
No.
That whenever the interrupt gets called, it
does come
configures
out.
the timer to get called whatever number I'm
Calls?
sending here. So 1,000
No,
ticks,
not
2,000
the
ticks.
calls.
It's just one line of code. Timers nowadays, they're pretty
No,
intelligent.
not the coils. This for this part.
The controller just
There.
takes care of everything else.
He's testing the blue motor. Is he testing the blue motor?
Seems that way.
The other lines are the steps from the driver.
Is he testing the blue motor?
Yes, Tony.
Yeah.
Is he?
Ideally, it would be a
Is he?
sine wave.
Why is he testing the motor?
How does that?
Why is he
So that's
testing the
actual
blue
current
motor?
through the windings right
Through the
now.
winding, yes.
So what happens when you put more load on it? I mean,
It doesn't matter. On a stepper, it doesn't matter because current always tries to reach infinity. So you are limiting the
so you
current.
control the current,
Yeah, if-
really.
If I do this,
Oh yeah, it changes a little bit probably from inductive or whatever.
oh, that's the back EMF
Yeah.
that is playing that role.
And so this is completely open loop.
It's
The only thing
completely
that's closed loop about this is the internal motor controller looking at the current
Dad,
and saying,
is those black
The
things
current
are
regulation is the only
magnets.
closed loop.
yeah,
Position and speed is open.
Electromagnets
right.
turn
And
this
and
way.
total torque and everything
And
is
it
still
turns
totally
it
open
here.
loop.
Well, total torque is given by what current you put. So that part, it is directly proportional to the part that you are controlling.
Right.
Because you are controlling the current.
It's
Is
pretty,
this
pretty
a
much,
worm gear?
since you're controlling the current, it
What
pretty
kind
much
of gear
stays the
is
same,
this?
even when you put a load on
Oh,
it.
yes, yes, yes.
Is in-
Now, if I apply a lot of torque, then it's gonna be
How do
steps.
you put a gear on?
There's,
Yeah.
this is so
Oh,
geared.
so it's, oh, so,
See it when it slips over.
right, it
Are you
slips, okay.
installing it?
I'm trying, but there is so much gear that I can.
Oh, got it, okay, it's geared, okay.
It's a lot more.
Okay.
You need to drop the curve down to
Yeah,
a lot.
I would need a
Attach the
small
motors to
screwdriver, but I have one extra driver to check. Oh,
It's the one.
Where are you?
the other cool thing is that you can change direction by just toggling on pins.
Oh.
I don't know if you can see this.
Oh, yeah.
Basically, very easy. The only problem that I see with steppers for mobile robotics is that they're just, I mean, the current, whatever current you put in there, it's always going to be there. On a DC motor, if the motor is not moving,
Oh,
or,
right.
I mean, or if the load is very light,
Is he
have
talking
one.
about the
or
blue
if the load is
motor?
more than you have
Yes.
2, 5, 10 amps. In here, if you configure it to move at 5 amps, even if the motor is not moving, the current is there, right? There is some current, well, I just say.
Where is it going, man?
Heating it up.
It is just maintaining, the good thing about
Why
steppers
is the
though,
motor heating?
is that if I stop it,
Oh, because it's going 50.
Is the motors
I
are
stop it,
heating? Did the
it is going to
motors heat
stop
up?
there, right? And you won't be able to move it. It will not move because the magnetic field that says this is where you have to be. is
If
still
you're
there.
keeping it energized, which you
Yeah,
are,
yes,
yeah.
yes.
Yeah.
The current must be whatever it is.
So it's a good way.
So there are advantages and disadvantages. Basically, the advantage is that you don't need a chef encoder and you can very easily determine how fast it's going and where it is at. This is why there's a lot of CNC projects on the web, like those rotor CNCs and laser CNCs, plasma cutters. They all use steppers. They just go to 0.00 and it's very easy to control where they go and cut. And of course, a CNC table, you're not going to move it. I mean, it's not a mobile robot. You don't use batteries. You plug
Right.
your 220 or your 110. Who cares? There are 5 amps at all times. Your bill will be larger, but if you can afford a CNC, you can afford it.
Right, yeah, right.
What else motor? The other motor that I have in here, this is a drill motor. I don't know if you have played with drill motors. The little back, I mean, these motors require a lot of current to move. They are so much geared that, I mean, you're supposed to put a drill through concrete if you wanted to with these drills. So I'm using a 30 amp driver for that. I mean, up to 30 amps.
What motor is he testing?
Drill motor.
But unloaded there, yeah, it was only like half an amp. But now I'm sure
Is the
when
motor-
inside this doll,
Is the drill motor the one with the long toe gear?
Concrete, what's inside.
What motor is he testing?
Drill motor curve.
What
That is-
what drill
That is
motor?
commutation current.
Would you see? What can I see? Which motor? Which motor?
On the table.
Which motor? I want to see
Right,
it.
right there. That one.
Sometimes you can see sparks on these motors.
Yeah.
And you can also smell them. Especially when that came from a $12 Harbor Freight.
Oh, yeah. Yeah, real high quality motor.
Yeah, super duper high. So as you can see, those,
Why did
and
it
some people
turn
actually
into
use that
spikes?
information
Don't hit me down.
to what is called sensorless speed control,
Yeah.
because that is a sensor right there. It is proportional to the speed that you're moving. So if you sample that with an analog to digital converter, you can say, this is my speed. So you don't need a chaff encoder, this is your chaff encoder, right?
oh, okay, so it's literally the commutator fault.
Yes,
not
commutator.
Okay, because there's also been the stuff about back EMF where
That's giving
you
you a frequency?
shut the motor off or shut off your driver and
Yes,
measure the
that's,
voltage. But that's slick, I mean, yeah,
Is
that's,
that giving
That's a
you a
great idea.
frequency readout?
yes, I mean, that thing is directly proportional
motherboard board.
to your
When
speed.
But that gets complicated when you're PWing though.
Okay,
That's
that's
it.
that's
So
RPM.
that is still it.
Oh, that is pretty good though. No.
Well, that's current, not voltage.
Right,
You can
yeah, you're right.
measure
It's
according to
current.
any